Welcome to Digestion and Physiology, Series 2, Part 4. Structural versus non-structural carbohydrates as an energy source. We now know that carbohydrates are an important source of energy for the horse, but what are the energy values of these different carbohydrates? Non-structural carbohydrates are mostly digested in the small intestine, especially sugars, primarily producing glucose, whereas structural carbohydrates are mostly digested through fermentation in the hindgut, producing volatile fatty acids. There are also alternative forms of energy. Fats and oils have 2.5 to 3 times the amount of energy as carbohydrates, but have some limitations to their use. Proteins can also be broken down and used as an energy source, but they are generally a poor source, making it a highly inefficient method. Let us look and see how we can make up the energy requirements for a horse from different types of feeds. In Australia, energy is measured in megajoules, while many countries overseas use the measure of megacalories. In this example, we will be using megajoules, and we are looking at a horse that needs about 70 megajoules of digestible energy each day. What can we feed that horse to achieve this daily energy intake? To get the equivalent amount of energy, 70 megajoules, into the horse, you could use 9 kilos of grass hay a day. Or you could use 8.6 kilos of lucerne or alfalfa hay per day. The main difference between the two different types of hay is the digestibility, not how much energy is in each feed. Lucerne hay is a bit more digestible than grass hay. The amount of digestible energy in a kilo of each hay type is virtually the same, about 8 to 9 megajoules. Your horse could eat 35 kilos of green pasture, high in moisture, to achieve the same energy intake as the 8 to 9 kilos of hay. The reason for the significant difference, about 4 times the volume, is because there is a high level of moisture in the grass. With more water, there is less dry matter, or the part of the feed that supplies the energy for the horse. This means the horse must eat a lot more of the grass to get the same amount of dry matter into its body as the much drier hay. Alternatively, you could feed 5.3 kilos of oats to achieve a daily intake of 70 megajoules of digestible energy. This means feeding a little bit more than half the amount of grass hay in the form of oats to achieve the same energy intake. But there are some major health benefits in providing structural carbohydrates, higher in hay and pastures, as opposed to non-structural carbohydrates, higher in grain. So what are the good, the bad, and the ugly parts of carbohydrates? Carbohydrates are the main source of energy for the horse. Structural carbohydrates or fibre, and non-structural carbohydrates, sugars and starch. Firstly, non-structural carbohydrates. Sugars are rapidly digested in the small intestine, but this may cause a problem with glucose levels in the blood rising too high, resulting in an insulin response when blood glucose levels rise. An insulin response is an increase in the speed and amount of insulin secreted. This insulin response, if it happens continuously from chronic exposure to high levels of sugar, can result in major health problems for the horse. This is the main cause of conditions like laminitis, equine metabolic syndrome, obesity, insulin resistance, the equine equivalent to human diabetes, and many other health issues. Constant exposure to high levels of sugars is, health-wise, not recommended. In fact, it is highly discouraged. Starch is more resistant to digestion in the small intestine, so less will occur here, unless it has undergone some sort of processing to cause gelatinization, which can increase small intestinal digestion and absorbance to as high as 90%. In one sense, with less starch digested in the small intestine, less will be converted into glucose, reducing the glucose level in the blood and therefore less insulin secreted. But because little is being digested in the small intestine, unless gelatinized, the remaining starch is going to end up in the hindgut, producing lactic acid, causing a pH drop, microbial death, acidosis, colic, leaky gut syndrome, laminitis, and more. Now, let's look at structural carbohydrates. When we start talking about structural carbohydrates, there are more benefits than disadvantages. The structural carbohydrates are fermented in the hindgut by the microbes. They produce volatile fatty acids, which provides much of the energy for the horse. They also produce a large quantity, and in most cases, the full requirements of B vitamins and vitamin K. These volatile fatty acids are short-chain fats, so they have 2.5 to 3 times the amount of energy than in the same quantities of sugars and starch. They travel through the blood as fats, not sugars, cool energy, so you get no insulin response, meaning a much lower risk of laminitis, insulin resistance, equine metabolic syndrome, and others. The downside, though, is that the fermentation process is slow. Fermentation of structural carbohydrates can take up to 48 hours to complete, so it is a slow release of energy. A very high level of energy, but a slow release. It is perfect for horses that need a constant, steady supply of energy, like endurance horses. However, this slow release of energy may not provide enough energy for a higher performing horse, like a racehorse or an eventer. This means if you have high-performing horses, it is important they have a lot of fibre in the diet, but you may also need to add something else to lift the energy content. So, in summarising Series 2 of Digestion and Physiology, carbohydrates are a chain of saccharide molecules which are primarily sugars. Common carbohydrates are sugars, starch, cellulose, and hemicellulose. Carbohydrates are categorized as either structural, cellulose and hemicellulose, or non-structural, sugars and starch. Structural carbohydrates are not readily digested in the small intestine. They need to be fermented by the microbes in the hindgut. Microbial fermentation produces volatile fatty acids, which have 2.5 to 3 times the energy density of sugars, but they travel as cool energy in the blood with no insulin response. Microbial fermentation of structural carbohydrates produces about 70% of the horse's energy requirements, but that is not enough for a higher performing horse. They need another high-level energy source as well. Sugars are easily and rapidly digested and absorbed in the small intestine, but they cause an insulin response because they travel through the blood as glucose. Sugars are a major cause of many nutritional diseases and disorders in horses, so it is important to be careful of grain and grain-based feeds in your horse's diet. Unprocessed starch is more resistant to digestion in the small intestine, with only about 1/3 to half digested, meaning quite a lot of it could end up in the hindgut, producing lactic acid and leading to major health issues. Thank you for watching Equine Digestion and Physiology Series 2 Part 4. If you like what you saw, please give us the thumbs up and share it with your friends. Connect to our website, our EqNC Facebook page and Instagram so as not to miss our next series.